What if the breathtaking precision of the perfectly fitted polygonal blocks at Ollantaytambo, Sacsayhuamán, and Cusco, and the mechanical perfection of Puma Punku at Tiwanaku, where there are massive identical blocks that, although scattered, fitted together like parts of a giant machine, were not carved but cast, molded and shaped like soft clay, hardened through a forgotten science by a civilization that predates written history. To build the polygonal walls, they filled large tear-resistant fabric sacks, most likely made from leather or woven plant fibers, with freshly prepared geopolymer while it was still soft, viscous, and highly malleable. This process naturally produced the tight, irregular polygonal shapes seen in the finished walls. To control the outer shape of the wall, a rigid outer sheathing, most likely wooden planks, was installed against the sacks. The imprints of this sheathing are still visible in many places. Small incisions for drainage were made in the bags once the material reached a semi-set state. Once hardened, these outlets became the small protruding nubs found on many stones. After curing was complete, the sacks themselves either decayed naturally or were removed, leaving behind the hardened geopolymer blocks. This explains why knobs usually appear near the bottom of blocks, why some stones lack them entirely, and why identical knobs occur worldwide. They are not symbols or handles, but fingerprints of stone casting technology. The surface texture of the fabric explains the uniform texture we see on the polygonal blocks today. Another possibility is that the blocks were individually poured into molds or against already cured blocks, and while still in a semi-wet plastic state, they were reshaped and pressed into their final positions. In this scenario, each new block was formed directly adjacent to earlier ones, allowing its surface to conform perfectly to the contours of its neighbors, achieving the seamless joints with minimal effort. This would explain why the interfaces between blocks often appear slightly curved rather than perfectly flat, as soft material naturally deforms under pressure. Small adjustments could be made during this phase, smoothing edges, sharpening corners, or correcting alignment before the material fully set. This process eliminates the need for repeated lifting and test fitting, which would be unavoidable if the blocks were carved from solid stone. There are numerous scientists who have tested these blocks under a microscope and concluded that they are geopolymer stones, suggesting that the builders did not fight rock but transformed it, shaping, molding, and casting it. Geopolymers are artificial stone materials created by mixing mineral powders rich in silica and alumina with alkaline solutions, producing a stone-like substance that hardens at low temperatures. Once set, geopolymers can match or exceed the strength of natural stone and are chemically stable for thousands of years. Crucially, while still wet, they can be poured into molds, shaped, and joined seamlessly. The precision of Inca polygonal masonry remains one of the most striking achievements of the ancient world because it appears to defy both gravity and conventional stoneworking logic. Across Cusco, Saksayhuamán, and other highland sites of the Inca Empire, massive irregular blocks fit together so perfectly that no mortar is needed and no measurable gaps remain. These stones are not simple rectangles but complex polygons with 5, 8, 10, or even more sides, each face shaped to match its neighbors exactly. This precision is not decorative, it is structural, forming walls that behave as unified systems rather than stacked blocks. What makes this even more remarkable is the size of the stones involved. Many blocks weigh several tons, yet they are fitted with the delicacy of watch components. Larger stones often rest on smaller ones without crushing them, distributing weight through perfectly matched contact points. In several walls, a single stone touches 5 or 6 others at once, each joint carefully shaped to absorb stress. The stones do not rely on gravity alone. They lock into place through geometry. This interlocking design is one of the reasons these walls have survived powerful earthquakes that destroyed later colonial buildings constructed with mortar. From a structural standpoint, this is highly sophisticated engineering, comparable to modern anti-seismic design principles. Achieving such interfaces through carving would require constant test fitting, removal, and adjustment, yet the results show no signs of cumulative error. Instead of widening gaps, the joints remain consistently tight across entire walls. This suggests a controlled shaping process rather than improvisation. The absence of visible tool marks adds another layer to the mystery. On many polygonal blocks, especially at eye level and along major joints, there are no clear chisel scars or percussion marks. Instead, what we see on many of these stones are smooth, shallow depressions often described as scoop marks. These marks are not random damage or erosion. They are deliberate, repeated, and appear in areas where fine shaping would have been required. Rather than the sharp linear scars left by chisels or hammerstones, these surfaces show rounded, concave impressions, as if material was removed while still soft or semi-plastic. What makes these scoop marks even more compelling is that they are not unique to the Andes. Very similar surface features appear at ancient stoneworking sites across the world, most notably at the Aswan Quarry in Egypt, where a gigantic, unfinished obelisk weighing 1,200 tons still lies attached to the bedrock. Along the sides and base of this obelisk, the granite surface is covered with rounded, shallow depressions that clearly look like they were scooped out while the granite was in a soft state. We see the same scoop marks at Stonehenge in England, at Domus de Janus in Sardinia, in Tlaloc statues in Mexico, and in many other advanced megalithic sites across the globe. Were all of these sites built by an advanced lost civilization that could manipulate stone at a chemical level long before the rise of the cultures we attribute them to today? What if the Inca, like the Egyptians and many others, were not the original creators of these techniques, but inheritors of structures already ancient in their own time? The consistency of these features across continents strongly suggests a shared technological approach rather than coincidence. Civilizations separated by oceans should not independently leave the same rare and unusual surface signatures. A remarkably interesting detail can be found on the walls of the inner temple of Coricancha, a feature so subtle it's often overlooked, yet so precise it may hold clues to a lost global tradition of megalithic engineering. Embedded between massive, multi-ton andesite blocks is a tiny, perfectly shaped stone, inserted with such meticulous care that it fits seamlessly into the larger structure. In fact, this small block in the center is not accidental at all. This stone marks the point of stress relief. On its own, this might be dismissed as a clever local technique, but what makes it especially intriguing is that similar small stone insertions can only be found on the oldest, most mysterious, and most complex megalithic structures all around the world. For example, the wall at Ahu-Vinapu on Easter Island, the Osirian of Abydos in Egypt, and even all the way to the Osaka Castle in Japan. Is this a simple coincidence, or an evidence for a now-lost global prehistoric civilization? One of the most overlooked yet technically significant features of Coricancha's construction lies in its corner joints, specifically the use of L-shaped stone blocks that seamlessly wrap around the edges of the walls. These cornerstones are not simply two stones abutting at a 90 degrees angle. They are single blocks meticulously carved into an L shape, designed to tie adjacent walls together into a unified structure. Again, we see the exact same technique all across the globe in Egypt. Does it not make more sense to accept that these stones were not quarried and carved, but are geopolymer that was shaped this way by lost global builders? A man named Marcell Fóti played a crucial role in reshaping how ancient stone construction is evaluated. Unlike speculative theorists, Fóti approached the question from a strictly experimental and material science perspective, asking a simple but powerful question. Can natural stone, including granite, be artificially recreated using chemical processes rather than carving? His research demonstrated that the answer is yes. By reproducing granite through geopolymer chemistry, Fóti showed that stone long believed to be immutable and purely geological can in fact be manufactured. He published a book titled The Natron Theory, where he explains how natron and other naturally occurring alkaline substances that were widely available in antiquity, especially in Egypt, could be mixed with powdered stone, water, and carefully controlled additives, creating a stone slurry that could be poured, molded, and shaped. Once hardened, the resulting material behaves like natural stone, including granite. This explains how civilizations could achieve razor-tight joints and massive stone elements in confined spaces that could never accommodate the manpower required to move solid blocks. What makes Fóti's work particularly compelling is that he does not stop at theory. On his YouTube channel, he documents the entire experimental process step by step, from raw mineral powders to finished artificial granite blocks. Viewers can see the mixing, casting, demolding, and final hardened stone, which visually and mechanically resembles natural granite. These videos demonstrate that the process works in real conditions, not just on paper, and that the finished stones can withstand cutting, polishing, and structural testing. The idea that ancient builders used geopolymer is not new, but it gained scientific footing when laboratory analyses began to reveal unexpected results. In studies led by Joseph Davidovits and his collaborators, samples from Puma Punku were examined using scanning electron microscopy, energy-dispersive spectroscopy, and X-ray diffraction. These techniques allow scientists to see the structure and chemical composition of stone at the microscopic level, revealing whether it formed naturally or was chemically bound. In natural sandstone, grains are cemented by geological processes over millions of years, forming a predictable pattern. In several Puma Punku samples, however, researchers observed an amorphous binder phase, meaning a glue-like material that holds the grains together but does not appear in naturally formed rock. This binder showed chemical signatures consistent with aluminosilicate geopolymers, a type of stone-like material created by mixing mineral powders with alkaline solutions. The tests also revealed something even more unusual: the presence of organic compounds inside the stone matrix. Natural volcanic andesite does not contain carbon-based binders, yet some samples showed traces of carbon and nitrogen distributed throughout the material. This suggests that an organic additive, possibly plant-based, was mixed into the stone when it was still in a wet, moldable state. In modern geopolymer research, organic additives are often used to improve workability, slow setting time, or control cracking, making this detail highly significant. The microscopic structure showed grains that looked poured together rather than fractured by carving, and in some cases, grains appeared rounded rather than broken. This rounding is typical of aggregates mixed into a slurry, not rock cut from a cliff. Together, these observations point toward a reconstituted stone rather than a natural block. The same research team compared quarry samples from nearby areas with stones used in the monuments and found inconsistencies that are difficult to explain with traditional carving methods. If blocks were carved directly from bedrock, their mineral composition should match the quarry almost perfectly, including grain orientation and cement structure. Instead, monument stones often showed a different internal texture, as if the original rock had been crushed, mixed, and reassembled. This is exactly how geopolymers are made today, by grinding stone into powder, adding an alkaline solution and allowing it to harden into a stone-like mass. In laboratory conditions, this process produces materials that are often stronger and more durable than natural stone. The idea that ancient builders used a similar method may sound extraordinary, but the evidence increasingly points in that direction. The precision of the blocks also becomes easier to explain once casting is considered. When stone is carved, internal corners are difficult to make perfectly sharp because tools cannot reach into tight spaces. At Puma Punku, many blocks have right angles so crisp they look like they were removed from a modern mold. Repeating forms are another major clue, as nature does not produce identical stones and hand carving rarely produces perfect duplicates. Molds, however, do exactly that, allowing the same shape to be reproduced again and again with minimal variation. The existence of standardized blocks implies a planned system, not improvisation, and suggests a construction process closer to manufacturing than to masonry. This changes how we must think about ancient Andean engineering entirely. In 2009, ground-penetrating radar revealed massive chambers beneath Puma Punku. To this day, the site has not been deeply excavated, and the current excavation is only at the 2-foot-deep mark, and archaeologists have never gone deeper. The official narrative of Puma Punku's construction is that it was built around 536 AD by the Tiwanaku civilization, a pre-Incan culture that flourished near Lake Titicaca in the Bolivian highlands. According to this account, the Tiwanaku people, armed only with stone hammers, ropes, and primitive tools, managed to quarry, transport, and carve the enormous sandstone and andesite blocks that form the ruins. Yet when we look at the scale and logistics of what that would require, the story begins to collapse under its own weight. Some of the sandstone blocks at Puma Punku weigh between 130 and 180 tons each. The official explanation claims that these colossal blocks were dragged into place with ropes and wooden rollers. But Puma Punku sits well above the tree line, at an elevation where no trees grow naturally. There would have been no timber available to make such rollers or sledges. The idea that the builders somehow brought up vast quantities of wood from lower elevations for a project of this scale stretches plausibility to the breaking point. Even modern equipment would struggle to haul multi-ton blocks across such a landscape, much less primitive tools and ropes. In the 1960s, the Bolivian army attempted to recreate the process, using only ropes and manpower to lift a 2-ton stone, less than 2% the weight of some of the largest blocks at the site. After hours of effort, they barely managed to move it a few inches. If modern men equipped with nylon rope and proper footwear could not shift a 2-ton block, how did an ancient civilization transport and precisely position stones weighing nearly 100 times more? The idea that copper chisels and stone hammers could carve perfect right angles and mirror smooth surfaces in volcanic rock is simply not possible. If you understand hardness and tool interaction, this is not a matter of speculation. It is a physical law. You cannot carve dense andesite with tools softer than the rock itself any more than you could slice steel with a plastic knife. The only plausible ways to shape and polish stone of that hardness are through the use of harder materials, such as diamond or corundum, or with advanced cutting methods involving high heat, vibration, or abrasion beyond what any Bronze Age culture possessed. The Tiwanaku, as far as history tells us, had none of these. In fact, even the first Europeans who discovered Puma Punku believed it was built by an advanced lost civilization. While Puma Punku often steals the spotlight for its impossible architecture, Tiwanaku itself tells an even deeper story, one of cosmic alignment, lost knowledge, and a people whose mastery of the natural world remains unmatched. What remains today is only a fraction of what once stood, a monumental city built of perfectly fitted stones, pyramids, temples, and plazas aligned with celestial precision. The ruins whisper of a forgotten civilization that reached an extraordinary level of sophistication long before written history began. Arthur Posnansky, an early 20th century explorer and researcher, dedicated much of his life to Tiwanaku and Puma Punku. He proposed that the complex was not built by the known Tiwanaku culture, but by a civilization that predated it by thousands of years. He spent over 50 years measuring, documenting, and analyzing every aspect of the ruins, eventually publishing his 4-volume masterpiece, Tiwanaku, The Cradle of American Man. In it, he presented a sweeping reinterpretation of Andean prehistory that directly challenged academic orthodoxy. Central to Posnansky's theory was the idea that Tiwanaku was not built around 500 AD as mainstream scholars maintain, but tens of thousands of years earlier during the final stages of the last ice age. He based this on the site's astronomical alignments. The Kalasasaya temple, he argued, was an ancient solar observatory. By studying the orientation of its walls and gateways relative to the sun's position at solstices and equinoxes, he claimed that Tiwanaku's builders had designed the structure to mark precise celestial events. But when Posnansky compared the temple's alignments to modern astronomical data, he discovered that they no longer matched the current solstitial positions. The angle of the sun's rising and setting had shifted. Using the known rate of axial precession, the gradual wobble of the Earth's axis, he calculated that Tiwanaku's layout would have been accurate around 15,000 BC. This conclusion, if true, would make Tiwanaku the oldest city on Earth, predating Mesopotamia, Egypt, and every known civilization by over 10 millennia. To Posnansky, this meant that Tiwanaku had been built by a people who existed long before the rise of recorded history, a culture advanced enough to understand astronomy, architecture, and engineering on a level that rivaled the modern age. He believed that these people had flourished before a great global cataclysm, possibly the end of the last ice age, wiping out most traces of their existence and leaving Tiwanaku as one of the few surviving testaments to their knowledge. Posnansky's dating was radical and his interpretation even more so. He envisioned Tiwanaku not merely as a city, but as the capital of an advanced civilization that once stretched across much of South America. He proposed that Lake Titicaca had once extended far beyond its current boundaries, covering much of the surrounding Altiplano. He also noted what appeared to be signs of glacial weathering on the stones, erosion patterns that, he argued, could only have occurred if the site had been exposed to massive floods or melting ice at the end of the Pleistocene epoch. In Posnansky's view, Tiwanaku was not a ceremonial center from 1,500 years ago, but the epicenter of a civilization that existed before the Great Flood, described in myths from cultures around the world. He connected these stories, whether from Sumer, Egypt, or the Bible, to a global memory of the same event that ended the age of the great builders. The same logic extends beyond Puma Punku to the great polygonal walls of Peru. Due to the many anomalies of Saksayhuamán and its unique walls, researchers and archaeologists have tried to explain the construction techniques logically. A Russian group of geophysicists carried out some work at the site in 2012. The group from Geo and Asociados, SRL, worked closely with Peru's Ministry of Culture to identify a few problems occurring at the site. The Russian team eventually took various samples from the rocks at Saksayhuamán. While their investigation was centered on better understanding the level of erosion on the blocks, they stumbled upon a few anomalies that further alluded to the idea of some kind of geopolymer being used at the site. When they published their results, they revealed that the limestone used at Saksayhuamán had an unusual composition, slightly different from that found in the nearby quarry. While the rock at the quarry was precisely what they'd expect to see, the stone from the megalithic walls at Sacsayhuamán had anomalies, which led them to speculate further about the possibility of a geopolymer being used. The scientists working on the project hypothesized that limestone blocks were sourced from the quarry. Yet, they may have been crushed into powder through the use of extensive bonfires, which would have weakened the stone before being made into a limestone paste from which blocks were molded. But if we are to believe this theory, then it should also be noted that the manufacturing of such blocks would have been on an industrial scale due to the sheer volume of the walls and structures at the site. The amount of mixture needed is almost incomprehensible to those who have worked on the theory. Even with the hydraulic paste or geopolymer theory, a lot of it still has yet to make sense. If working with cement, why make such large blocks? Were the blocks molded and then moved, or were they built upon one another? And finally, if such blocks were the geopolymer or made from a cement-like paste, how did they become so strong that it has withstood enormous earthquakes over the last 1,000 years? Yet Spanish churches built long after have crumbled into dust on several occasions. It appears there is more than meets the eye when it comes to Sacsayhuamán, and in fact, there's still evidence to suggest that the rocks themselves were quarried and not shaped. The unique properties of the limestone blocks that constitute the massive walls of Sacsayhuamán are a subject of great interest and scientific study. These properties are not commonly found in limestone and suggest a fascinating geological history linked to the site's proximity to volcanic activity. The nearby Rodadero Formation, an ancient geological site, provides critical clues to this mystery. The Rodadero Formation is known for its historical volcanic activity, characterized by a significant flow of lava from its center. This geological phenomenon is crucial in understanding the unique characteristics of the limestone used in Sacsayhuamán. Limestone, a sedimentary rock, typically forms in marine environments and is primarily composed of calcium carbonate. However, under certain conditions, such as exposure to intense heat, limestone can undergo a process known as recrystallization. The limestone blocks in the walls of Sacsayhuamán exhibit these distinctive properties, suggesting that they might have undergone such a natural recrystallization process. This geological transformation would not only explain the durability and longevity of these stones, but also their ability to withstand the seismic activity that is common in the Andean region. The precise fitting of the stones, a hallmark of Sacsayhuamán's construction, might have been facilitated by the altered texture and consistency of the recrystallized limestone. But what kind of technology did the ancients possess to be able to produce such intense heat equivalent to volcanic activity? How did they recrystallize the limestone, endowing it with the strength and durability that have allowed this magnificent structure to stand the test of time? We see the same thing in Cusco's megalithic walls. Some of these joints appear fused or vitrified. There is a glassy sheen on certain seams, suggesting that intense heat may have been applied to partially melt the stone surface, a possibility that mainstream archaeology has yet to fully address. Alternative researchers argue that this vitrification may indicate the use of high-temperature stone fusion technology, perhaps using unknown tools or even advanced materials chemistry. Others suggest acoustic tools, or the manipulation of resonance frequencies to soften or levitate stone. While these ideas are speculative, they are rooted in a simple fact. The observable evidence cannot be easily reproduced with Bronze Age tools. This level of engineering is so far beyond the rest of Inca construction that it may represent a legacy of a far older and more technologically advanced culture, perhaps one that existed long before the Inca adopted Cusco as their capital. The Inca themselves seem to admit this in their legends. When Spanish chroniclers asked them who built the great stoneworks of Cusco and Sacsayhuamán, some Inca nobles replied that they were made by earlier peoples, sometimes described as giants, sometimes as the god Viracocha's followers. These were not casual statements. They reflect a deep cultural memory that the finest megaliths were inherited, not created by the Inca. When the American explorer Hiram Bingham first brought Machu Picchu to the world's attention in 1911, the focus quickly turned to its stunning stone terraces, temples, and breathtaking mountain setting. Yet in the years that followed, another discovery associated with Bingham's expedition sparked curiosity and controversy: the elongated human skulls unearthed in and around the site. To mainstream archaeologists, these were examples of cranial deformation, a cultural practice known from many ancient societies. But to others, their unusual size and extreme shape hint at the survival of a lost prehistoric people, perhaps the true architects of Machu Picchu, the great stoneworks of Cusco and Sacsayhuamán. During Bingham's Yale-Peruvian expedition from 1912 to 1915, a series of excavations were carried out at Machu Picchu, its cemeteries, and surrounding caves. The team recovered dozens of human remains, including skulls that did not resemble typical Andean crania. Several of these were elongated with sloping foreheads, enlarged cranial vaults, and exaggerated cranial capacity. The skulls were carefully packed and shipped to Yale University along with artifacts, pottery, and other finds. Some were later displayed or described in reports, though often overshadowed by the architectural revelations of the site. But even Bingham himself noted how peculiar they appeared, hinting that Machu Picchu might have been inhabited by a very different population before the Incas ever arrived. The mainstream explanation for elongated skulls in the Andes is artificial cranial deformation. This practice, widespread among Andean societies, involved binding an infant's head with cloth, boards, or cradle boards to reshape the skull as it developed. The result was a tall, elongated cranium seen as a mark of nobility, beauty, or status. Indeed, such skulls have been documented across Peru, Bolivia, and Chile, especially among the Paracas culture of the southern coast. But here lies the mystery. Why would an entire society come to believe that an elongated skull was the visible sign of power, superiority, or divine connection? One powerful theory is that the practice of cranial deformation was an imitation of a real, earlier population that naturally bore elongated skulls. These individuals, whether a distinct race, a hybrid group, or a prehistoric elite, would have stood out physically from the general population. Their appearance and technological superiority would have marked them as different, perhaps even divine. Later cultures, including the Incas, may have copied this physical trait artificially, binding their infants' heads to resemble the ancestral elites they revered. Over time, cranial elongation itself became a status symbol, not because it had functional value, but because it visually linked Inca nobility to the legendary builders of the past. However, the skulls associated with Bingham's excavations raised deeper questions. Some skulls appeared far more extreme than typical examples of cultural cranial shaping. The slope of the forehead and cranial dome in certain specimens seemed beyond what binding alone could produce. Reports circulated that these skulls had larger than normal brain volumes, suggesting a physiological difference rather than mere reshaping. While many of these claims remain contested, they fueled speculation that the skulls belonged to a distinct population. In the decades since Bingham's discovery, the elongated skulls have been absorbed into a larger narrative of pre-Inca civilizations in Peru. Alternative historians and researchers argue that these skulls may represent the remnants of a different race or culture, one that predates the Inca by centuries or millennia. The argument goes that the same mysterious population responsible for the elongated skulls also built the most advanced megalithic stonework of the Andes, the finely fitted mortarless walls of Sacsayhuamán, Ollantaytambo, and Machu Picchu itself. Later Inca people, though skilled builders, could not replicate this megalithic perfection. Instead, they found, reused, and repaired the older ruins. The skulls may be the biological remnants of these prehistoric master masons. This could also be the reason the later Inca people tried to look like these technologically advanced ancestors, deforming their cranial shapes. Elongated skulls are not unique to Peru. They have been found in Egypt, linked to Amarna's royal family like Akhenaten and Nefertiti, in the Caucasus, in the island cultures of Melanesia, and among ancient peoples of Central Asia. This global pattern suggests to some a shared prehistoric tradition or even a widespread ancient civilization, with Peru's elongated skulls as one branch of a global phenomenon. Ask any archaeologist today about Machu Picchu, and the answer comes swiftly and confidently. It is a 15th century royal estate built by the Inca Emperor Pachacuti around 1450 CE. According to the Orthodox narrative, Machu Picchu was conceived as a luxury retreat and sacred ceremonial center perched high in the Andes. Its agricultural terraces fed the residents, its temples honored the sun and the mountain gods, and its breathtaking setting made it a spiritual nexus for the Inca elite. Some suggest the megalithic foundations could be 2,000 to 3,000 years old, linked to pre-Inca cultures like the Pucara or Tiwanaku traditions. Others push further back, proposing an age of 10,000 to 12,000 years, tying Machu Picchu's origins to the end of the last ice age, when global cataclysms may have destroyed an advanced prehistoric civilization remembered in myths of Atlantis or Viracocha. The fact that similar megalithic techniques appear at sites across the world strengthens the case for a much older advanced megalithic civilizations, predating the Incas by millennia. Long before recorded history, there were advanced ancient civilizations capable of building gigantic megalithic structures we can't build today, lifting enormous stone blocks weighing thousands of tons and stacking them with laser-like precision. Blocks we still struggle to lift even with our modern cranes. They crafted mathematically precise, flawless monuments from the hardest stone on Earth, leaving us to wonder who these builders were and how they accomplished the impossible. Were they merely primitive societies, or were they masters of a forgotten technology lost to the sands of time? Uncover the evidence of an ancient, global, and technologically sophisticated civilization that once ruled over our planet, constructing gigantic sites the ruins of which are still standing, before a cataclysmic event erased it from memory. Access our ebook, Prehistoric Megastructures, a nearly 500-page volume packed with images and in-depth analysis of some of the most astonishing and unexplained ancient structures ever discovered, monuments that were clearly built with advanced technology from a time long forgotten. There's a limited discount on the ebook, so make sure to get yours before it's too late.